Ever wondered what's really going on under the hood of a platform that's powering some of the most cutting-edge data and AI work on the planet? Well, today, we're going to pull back that curtain on the Databricks architecture. And trust me, this is way more than just a technical diagram. It's the actual blueprint that makes a unified approach to data, analytics, and AI even possible. All right, let's get into it. So here's the game plan. We'll kick things off by looking at the age-old problem Databricks was built to solve, that classic split between data lakes and warehouses. From there, we'll dive into the three core pillars of the architecture. Then we'll clear up the super important difference between the control and data planes. And finally, we'll see how all the different people, from engineers to analysts, actually use this thing. You know, to really appreciate what the Databricks architecture does, you have to understand a bit of the history. For years, data teams were basically stuck between a rock and a hard place, forced to make this really fundamental and often really painful choice. And that choice was this. Do we go with a data lake, something super scalable but kind of messy for all our raw and unstructured data? Or do we build a data warehouse, something that's fast, well-governed, but also pretty rigid for our structured, need-it-now analytical data? And that single decision had massive ripple effects on what a business could actually do with its own information. This created a huge divide. On one hand, you had data lakes. They were built on cheap cloud storage, they were incredibly flexible, great for stuff like machine learning, but they often lacked the reliability you needed for business intelligence. Then you had data warehouses, which were the complete opposite. They were rock solid, secure, and fast for BI, but they really struggled with different kinds of data, and man, they were expensive to scale. So what happened? Companies had to maintain two totally separate, complex systems, which just created data silos and a nightmare of pipelines trying to keep everything in sync. The solution to this whole mess is the Lakehouse. And it's not just a hybrid, it's a totally new way of thinking. It's an architecture designed from the ground up to give you the best of both worlds, all on a single platform. It finally lets data engineers, scientists, and analysts all work together on the exact same data, a single source of truth, ending that historical friction for good. So how does Databricks actually build this Lakehouse? Well, it all rests on three foundational pillars. They work together seamlessly to govern, store, and process all of your data. Let's break them down one by one. The first, and you could argue the most critical pillar, is unified governance. This is all powered by a service called Unity Catalog. The easiest way to think of it is as the platform's universal librarian and its security guard, all rolled into one. It gives you one central place to govern every single data and AI asset you own. Now, what's so powerful about Unity Catalog is how it organizes everything. It uses a super clear three-level structure. You have a catalog, which holds schemas, and schemas hold the actual assets, like tables or models. This hierarchy lets you grant permissions using standard SQL, which makes managing security feel really familiar. And because it sees everything, it automatically captures data lineage, so you can see exactly how your data is moving and changing across the entire platform. It's pretty amazing. Okay, pillar number 2. This is the storage foundation itself, and it's called Delta Lake. Now, this isn't just another file format. It's an open source storage layer that brings bulletproof reliability to your data lake. This is the magic that makes your data time travel capable and just incredibly robust. So here's the key. What does Delta Lake add on top of a standard format like Parquet? Well, for starters, it brings ACID transactions. Think of it as an all-or-nothing guarantee for your data operations. This means a job either completes perfectly or it's like it never happened at all, which prevents the kind of data corruption you get when a job fails halfway through. It also enforces your data schema, so no more garbage data sneaking in, and it keeps a full version history, letting you literally query or restore your data from any point in the past. And that brings us to our third and final pillar, intelligent compute, the engine that does all the heavy lifting. Databricks uses a really powerful 1-2 punch here. It's built on the legendary open-source engine Apache Spark for maximum compatibility, but then it's been supercharged by a high-performance engine they built called Photon. So what's the big deal with Photon? It's a native C++ vectorized query engine. And what that really means is, instead of processing your data one slow row at a time, it processes huge batches all at once. The result? It dramatically speeds up SQL and data frame workloads. We're talking up to 12 times faster in some cases. And the best part is, you don't have to change a single line of your code to get that boost. Okay, now that we've seen the core building blocks, let's look at how the platform actually operates day to day. This is where understanding the separation between the control plane and the data plane becomes absolutely essential, especially for security and management. Think of it like this. The control plane is the brain of the whole operation, and it's fully managed by Databricks. It runs the web interface, it schedules all your jobs, and it manages all the metadata. Now here's the crucial part. Your actual data does not live here. The data plane is where your data stays, safe and sound in your own cloud account. It's also where all the heavy lifting, the actual data crunching, happens. But wait, that data plane isn't a one-size-fits-all kind of deal. It actually comes in two different models, and this is really key to the platform's flexibility. First, there's the classic model. This is where compute clusters spin up directly inside your own cloud account. You manage the networking, which gives you complete control over security. But then you have the serverless model. Here, the compute runs in a secure environment managed entirely by Databricks. And the huge win here is that you no longer have to worry about managing infrastructure or capacity or paying for idle computers. Databricks just handles all of it for you. So we've covered the what and the how. Now for the most important part, the who. An architecture is only as good as the people who use it, right? So let's look at the key roles that really bring the Databricks platform to life. First up, you have the gatekeepers, the administrators. Account admins are at the very top. They oversee the entire account. Workspace admins manage specific team environments. And Metastore admins are the guardians of governance, controlling all the data access and policies within Unity Catalog. Basically, they set the rules of the road for everyone else. Now, with those roles in place, we can meet the builders, the explorers, and the analysts. These are the functional personas who are on the front lines using the platform every day to drive real value from data. Data engineers are the architects of the data flow. They use awesome tools like Airflow to build really reliable and easy-to-maintain pipelines. Their main job is to take all that raw, messy data coming in, clean it up, transform it, and make it pristine and ready for analysis and machine learning. Next up, the data scientists. They take that beautiful, clean data and use it to build the future. They're using tools like Mosaic AI to build generative AI apps and MLflow to track every single experiment, making sure their work is repeatable and organized. And because they're on the same unified platform, they can go straight from experimenting to deploying models into production without ever hitting those awful data silos. And finally, we have the data analysts. They're the ones who turn all that data into answers. Using Databricks SQL, they can run lightning-fast queries directly against massive data sets right in the Lakehouse. They build the dashboards and reports that give business leaders the insights they need to make smart decisions. So, when you put it all together, the Lakehouse idea, those three pillars, the smart operating model, and all these different people working together, you finally get it. It's not just a random collection of tools. It's a truly unified platform where everyone, and I mean everyone, can work together on a single copy of the data. And that really brings us to the final thought here. This whole architecture is designed to break down the technical barriers that used to exist between data lakes and warehouses. But its real power? That comes from breaking down the human barriers between teams. So the question I want to leave you with is this. With the technology unified, what silos can your team break down next?